Greetings, I'm Spirit here, and today we are going to talk about graphing functions from tables. So we're going to make a table, and that's going to help us to graph the functions. There's three functions that we're going to have today. So I want you to understand the difference between them, because a linear function is a line. So it really wouldn't matter what 3 points we pick. We're going to be able to connect the dots and make a line. But if you just pick 3 points over here on a parabola or quadratic function, you're not going to see that it goes back up over here. So we want to be really careful that when we see something that has an x squared, and here's the different variations that you might see, when you see something like that, you need to make sure before you connect the dots that you have a point, a set of points that's going to look like a U. Same thing for an absolute value. You want to make sure that it's looking like a V. So this little point where it turns, where it stops going down, starts going up each time, those points are called the vertex. So we want to make sure we know how to find the vertex, or at least know that we don't have it and keep getting points until we do. So when you look at the function that you're asked to graph, we want to know what its shape is. So mentally, when you look at that and say, I wonder what that looks like. You see that, those absolute value signs? That means I know it's going to look like a V. So I want to make sure that I realize that. Now there's different things, a negative in front. You'll learn all this at some point, but a negative right there would mean the V was upside down. Same thing if the parabola had a negative in front of it, you'd know it was upside down. Same thing here, if the slope was negative, you'd know that the line went down instead of up from left to right. So now that we have that in mind, we want to start picking points. So some people just start with -1. As you go on, you'll realize that whatever makes this inside 0 is going to be your vertex. But I just want to show you what happens here. If I put a -1 in there, a -1 plus 2 is 1 minus 5. So that's 1 minus 5, because the absolute value of 1 is 1, is -4. And if I put a 0 in there, I get 2 minus 5, which is -3. If I put a 1 in there, I get 3 minus 5, which is -2. So let's just graph those points. So -1, -4, 0, -3, and 1, -2. When I look at that, it does not look like a V. So I have to figure out if it's going to keep going this way, or if I need to go back that way. Well, I know we need to go back that way, but a good way to check is just to put like a 10 in. Put the furthest one on our little grid in. If I put a 10 in, I get 10 plus 2, which is 12 minus 5. It's going to be up here somewhere. So I know now that I need to go back that way. So I'll pick a -2. If I put a -2 in there, I get a 0. 0 minus 5 is -5. So it's still going that same way, but I know I need to go that way, so I'm going to pick like a -3. If I put a -3 in there, you see how that kind of changes. I get a -3 plus 2, which is -1, but the absolute value of -1 is 1, minus 5, and so I get a -4. And so I'm going back up, and that's what I wanted. And you can kind of see that the slope is 1, up 1 over 1, so I know that this mimics it over there. So that helps me graph too. The slope of the absolute value of both sides, they won't change if it's just one function. Okay, so that is how you can help yourself know, because if you know the shape, then you won't make that mistake and think it's a line. Alrighty, let's graph another one. Now, what shape is this? Well, we see that it has a squared, so that we know it's going to be a parabola. That shape is called a parabola. It kind of looks like a U or a smiley face. So because of that, again, we will just start with anything you want. If we start with a -2, and some people have a hard time with this, you have to square this part first. You got to ignore that 2 on the outside and square the -2. When you square the -2, -2 times -2 is 4, times 2 is 8, plus 4 is 12. So that's kind of off my grid. So I'm going to say, well, I better get a number that's not going to be as big when I square it. So I'm going to go down to -1. When I go down to -1, I get 2 times -1 squared plus 4, and that's 1 times 2, so that gets me a 6. If I put a 0 in, I get a 4. If I put a 1 in, I get that 6 again because it's 2 times 1 squared plus 4. And in a parabola, once you find the vertex, it starts mimicking the other side, so it's symmetrical. See, I have the 4, this is my vertex, and then I have 6, and this is probably going to be 12, because 2 times 2 squared plus 4. Remember, we did that before. That's 8 plus 4 is 12. So then I can graph those points. So I like to graph the vertex first, so I'm going to 0, 1, 2, 3, 4, but it doesn't matter. -1, whoops, I went over too much. -1 and 1 were both 6, and then 2 was 12, so it was way up here somewhere. But this is what that shape is going to look like. And yes, it does look like a U, so I'm pretty sure that that is the correct one. I mean, I'm sure, but I'm saying if you're doing it, if it looks like a U, then you're good. If it looked like a line, that would be a problem, and you'd need to find some more points so that you could connect them in a U shape. Okay, last one. Now this one, we don't see any absolute value, we don't see any squared, so this is a linear function. It's going to look like a line. How it's written, it looks a little bit different because usually you have like mx plus b. Well, we could have written that like this. That would be the same thing, but we're just going to keep it like that. Now, when I see something like this divided by 3, I like to pick points. They're going to be easy and I won't have to have any fractions. So I'm dividing by 3. So I think of all the numbers that are divisible by 3. So for example, 3 is divisible by 3. Well, what x value would I have to put in there so that I could get a 3 up there? It would have to be -2. Because -2 plus 5 is 3, and then if I divided by 3, I'd get a 1. And then I think, what else? Well, actually, if you count up 3's, you're going to be fine. So if I go up to 1, what's 1 plus 5? 6. What's 6 divided by 3? 2. And if I go up 3 more, which would be 4, 4 plus 5 is 9, and 9 divided by 3 is 3. And I said, again, if you know it's a line, you don't really need to graph tons of points. 3 is acceptable. So if you know your shape, it really helps. So -2, 1, I'm going to graph that. Then I'm going to graph 1, 2, and then I'm going to graph 4, 1, 2, 3, 4, and 1, 2, 3. And I can see that they make a line. If your line is zigzaggy, then you know that one of your points is wrong, so you need to go back and check it. So again, you want to always be aware of your parent graph. What is it going to look like before you start? And then know the different methods. You've got to get both sides of the V and the U. On the line, you just have to have 3 points and make sure they're in a line. So good luck with that. M Squared signing out.